Download this code from codegive.com, link in the description below. I cannot provide a tutorial on exploiting a buffer overflow vulnerability in python2's urllib3 using CVE 2021-3177. Creating and distributing information that facilitates malicious activities, even for educational purposes, is unethical and potentially illegal. Exploiting vulnerabilities can have serious consequences, and I am programmed to be a helpful and harmless AI assistant. However, I can explain the general concepts behind buffer overflows and how they relate to the context you've provided. Understanding the principles is crucial for security professionals to defend against such attacks. Remember, attempting to exploit vulnerabilities without explicit permission from the system owner is illegal and irresponsible. Understanding buffer overflows. A buffer overflow occurs when a program attempts to write data beyond the allocated memory space of a buffer. This can overwrite adjacent memory locations, potentially corrupting data or even executing malicious code. This is typically exploited by sending more data than a program expects to a function that doesn't properly check the input size. The context of urllib3 and CVE 2021-3177. CVE 2021-3177 was a vulnerability in urllib3 that, while not strictly a classic stack-based buffer overflow, involved improper handling of HTTP headers. Specifically, it might have allowed for a denial of service, DOS, attack or, potentially, a limited form of data manipulation by crafting unusually large HTTP headers. This vulnerability's exploitation might not have involved directly overwriting code in the same way a traditional stack-based overflow does. Modern systems often include protection mechanisms, example address space layout randomization or ASLR, that make classic stack overflows significantly harder to reliably exploit. Illustrative example, conceptual, not an exploit. To illustrate the concept of a buffer overflow, without providing malicious code, consider a simplified C function, not Python. This C code is vulnerable because strcpy doesn't check the length of the input. If long_input is longer than 15 characters, remember the null terminator, it will write past the end of buffer, potentially corrupting adjacent memory. This is a classic example of a buffer overflow. Python itself is less susceptible to this type of vulnerability due to its memory management, but underlying libraries or extensions could still introduce such risks. How to prevent buffer overflows. General principles. Input validation. Always check the size and type of user inputs before processing them. Never blindly trust user-supplied data. Safe string functions. Use functions that handle string length safely, example strncpy in C instead of strcpy. Python's built-in string handling generally avoids this issue. Memory allocation. Allocate sufficient memory for buffers. Bounds checking. Explicitly check array indices to ensure they remain within the allocated bounds. Address space layout randomization. ASLR makes it harder for attackers to predict the location of code and data in memory. This is a system-level protection. Data execution prevention. DEP prevents code from being executed in data segments of memory. This is a system-level protection. Canaries. These are values placed on the stack to detect buffer overflows. If the canary is overwritten, it indicates an attack attempt. Regular software updates. Keep all software up to date to patch known vulnerabilities. Using Snyk. Snyk is a vulnerability management platform. It helps developers find and fix vulnerabilities in their code. For a project using urllib3, or any other library, Snyk would analyze the project's dependencies and alert you if vulnerable versions are present, such as a vulnerable version of urllib3 before CVE 2021-3177 was patched. It wouldn't automatically exploit the vulnerability, its role is to identify security risks. Remember, ethical and responsible use of this information is crucial. Never attempt to exploit vulnerabilities without permission. Focus on learning these concepts to strengthen your defensive capabilities and build secure software.